Metal ions undergo a variety of equilibria in aqueous solutions, and it's useful to be able to determine the fraction of the metal that's in a given species form. Let's consider a simple reaction between a metal and an electron pair donor we'll call ligand that forms a new coordinate covalent bond known as a metal complex. There's an equilibrium constant for the formation of that complex that can be described in terms of products over the reactants. And we'll not bother putting the charge on the complex. Let's talk about the fraction that's in the free metal form. So that's the concentration of the unbound metal compared to all of the species containing the metal. So this is the fraction in the free metal form, Mn plus form. Let's remove these things that we don't have a direct handle on and replace them with things that we can measure or control or look up in tables. So let's divide the numerator and the denominator through by Mn plus. So we get 1 in the numerator, 1 first term in the denominator, and then Ml divided by the ion form. Well, this is very similar to the expression for the equilibrium constant. There's that ratio that we want. Let's just move the ligand form over on to the left with the Kf value. And then we have the ratio that we're interested in, Ml over Mn plus. So substituting, we get 1 over 1 plus Kf times the ligand concentration. Likewise, if we want the fraction in the complex form here, that's just Ml over M for the ion plus Ml. Again, dividing through by Ml, it's 1 over Mn divided by Ml plus 1. Now this ratio is reciprocal of what we had before, so substituting we get 1 over 1 over Kf times the ligand plus 1. And to remove the fraction inside the fraction, let's multiply through by Kf over L, and we get our final expression, Kf in the top times the ligand over 1 plus Kf times the ligand. Once again, we get an expression that has a similar denominator to the fraction we were using for the metal itself, and the term in the numerator comes from a term in the denominator. Let's look at a little more complicated case. Specifically, let's consider the complexation of iron with chloride ion, and we know that it goes to form an iron Cl plus 2 species. And there's a Kf or K1 for this first step, and it's the products over the reactants. And there's another formation, a complex formed, that represents this complex combining with another chloride ion to form a higher order chlorocomplex, and it has an equilibrium constant. Yet another complex forms as the chloride concentration goes up. And there's an equilibrium constant, K3. And there's one more step that's common at modest chloride concentrations. And there's an equilibrium constant for the formation. So these reactions are known as stepwise formation processes, and there's stepwise formation constants then that go along with those. Just as before, we can calculate a fraction in any given form. So the fraction in the free unbound metal ion form turns out to be 1 plus the first equilibrium constant times the ligand to the first power. The next term is the first two constants times the ligand concentration to the second power. Next term is K1, K2, K3 times the ligand to the third power. And finally, product of all the K's to the ligand concentration, times the ligand concentration to the fourth power. Term in the numerator comes from a term in the denominator. And if we think of the species in order of increasing complexation, we go from the free metal to 1 ligand, 2 ligands, 3 ligands, and 4 ligands. There's 5 species. So we start on the left-hand side of our denominator, and the 1 is the first term in the denominator. It's also goes in the top when we're interested in the first member of this series. Likewise, if we want the form for the iron in the, say, Cl3 form, it would be the same denominator. And this one has 3 chlorides on it. It's 1, 2, 3, fourth member in the family. So we count over 2, 3, 4. So the numerator is K1, K2, K3 times the chloride or ligand concentration cubed. So also the ligand, the power for the ligand is the same as the number of ligands on the complex that we're interested in.